Hello everyone. In this video, we shall deal with equations in quadratic form. So what are equations in quadratic form? These are equations which will lead to a quadratic equation or equations that can be reduced as a quadratic equation. So let us have an example. Let us solve x to the fourth minus 2x squared minus 15 equals 0. Observe that this equation is of degree 4, which is not a quadratic equation. However, we can let a dummy variable, let's say m, to represent x squared. So why are we choosing x squared? Because if we square both sides of this equation, we're getting m squared equals the square of x squared. And the square of x squared is x raised to 4. So every occurrence of x to the fourth will be replaced by m squared, and every occurrence of x squared will be replaced by m. So our equation here can now be written as m squared minus 2 times m minus 15 equals 0. So using factoring, we can factor the left-hand side as m minus 5 times the quantity of m plus 3. And then, using the zero product property, we can equate both factors to 0, and eventually we solve for the values of m. In this case, m is equal to positive 5, and for the second equation, m is equal to negative 3. However, since our original equation involves x, so we shall write the dummy variable m back to x squared. So our first equation is now x squared equals 5, and our second equation is x squared equals negative 3. Now, using the square root property, then we have x is equal to positive negative square root of 5. And then for the second equation, we get x is equal to positive negative square root of negative 3. But square root of negative 3 can be written as square root of 3 times the imaginary number I. So these are the solutions of our equation. Now let's have a second example. Let's solve 2 times x raised to 2 thirds minus 5 times x raised to 1 third minus 3 equals 0. So here, we can let m as the dummy variable, which is equal to x raised to 1 third. And then if we square both sides of that equation, we're getting x raised to 1 third quantity squared, which is equal to x raised to 2 thirds. So every occurrence of x to the 2 thirds will be replaced by m squared, and every occurrence of x raised to 1 third will be replaced by m. So our original equation can now be converted into a quadratic equation involving the variable m. So we get 2m squared minus 5m minus 3 equals 0. So factoring the left-hand side, we get 2n plus 1 times m minus 3. So using the zero product property, we can equate both factors to 0, and then we can solve for m. So for the first equation, we transpose positive 1 to the other side, so we get 2n equals negative 1, and then dividing both sides by 2, we get n is equal to negative 1 half. And then for the second equation, m is equal to positive 3. But since the dummy variable m represents x raised to 1 third, we can write it back to x raised to 1 third and equate it to negative 1 half. And for the second equation, we have x raised to 1 third is equal to positive 3. Now, in order to solve for x, then we have to apply the cube to both sides of the equation. So x raised to 1 third when raised to 3 will become x, and the negative 1 half raised to 3 is equal to negative 1 over 2. And then for the second equation, also we get the cube of both sides of the equation, and so we get x is equal to 3 raised to 3, which is 27. Now, since our equation contains rational exponents, which are actually represented by radicals for the cube root because the denominator of the fractional exponent is 3, then we can check. We have to check if these um, values of x would satisfy the given equation. So I will not anymore show it, but you need to check if the values of x will satisfy the following equation. And then for our last example, let us solve for 2x squared minus 3x quantity squared minus the quantity of 2x squared minus 3x minus 2 equals 0. So just like the previous two examples, we will let n to be 2x squared minus 3x. And then if we apply the square to both sides of this equation, we're getting 2x squared minus 3x quantity squared. So that means the original equation can now be written as n squared minus n minus 2 equals 0. Factoring the left-hand side, we will get m minus 2 times m plus 1 equals 0. And then applying the zero product property, we equate both factors to 0, and then we solve for m, which gives us n equals 2 and m is equal to negative 1. However, we have to write the dummy variable m back to the original variable x using the following relationship. So m is 2x squared minus 3x, and then equate 2, and then we have 2x squared minus 3x, and then equate it to negative 1. So for our first equation, since this is a quadratic equation in the variable x, we can transpose positive 2 to the left side, and we get 2x squared minus 3x minus 2 equals 0. Resolving this equation, so factoring the left side, we get 2x plus 1 times x minus 2. So using the zero product property again, we can equate both factors to 0. And so in the first equation, we get x is equal to negative 1 half. And in the second equation, we get positive 2. Now for the second equation here, transposing negative 1 to the other side, we get 2x squared minus 3x plus 1 equals 0. And then again, factoring the following, we will be getting 2x minus 1 times x minus 1. And again, using the zero product property, we equate both factors to 0. And then solving for x, we get x equals positive 1 half and x is equal to positive 1. So our solutions for the given equation are negative 1 half, positive 2, positive 1 half, and positive 1. So thank you for listening about equations in quadratic form, and I hope that you can subscribe to my YouTube channel. Thank you.